Hello everyone, welcome to the SunRISE Ground Radio Lab. I'm Sheers, researcher in the Department of Climate Space Sciences, and I'll be your host for all these self-training module sessions. Our SunRISE GRL program is in collaboration with SunRISE Space Mission and Radio Jove project. Here, I really acknowledge my team and NASA funding grants to turn this project possible. So this is the very first section of our training module sessions. In this module, I'm going to introduce SunRISE Space Mission, Radio Jove project, and SunRISE Ground Radio Lab. The Sun Radio Interferometer Space Experiment, or SunRISE mission, is a low radio frequency interferometer in space to understand the nature of solar radio burst. SunRISE uses a space-based array composed of 6 small satellites, or we call them CubeSats, flying in the supersynchronous geosynchronous Earth orbit within the 10-kilometer separation with each other, and creating an artificial or synthetic aperture for the radio telescope to observe solar radio emissions. This mission will aid understanding about how solar energetic particles accelerate and correlation between type 2 solar radio burst and the formation of CMEs. A few major science objectives of this mission includes to discriminate competing hypotheses for the generation of solar energetic particles, to associate and correlate type 2 radio burst and emission of coronal mass ejections, and to reconstruct magnetic field lines associated with type 3 solar radio burst. And there are many more others. This mission concept is proposed by Dr. Justin Casper and his team from University of Michigan in the year of 2016. After successful completion of their science traceability matrix as a phase A, it turned to phase B in the year of 2020 for mission formulation. At present, this mission is scheduled for launch on September 2024. After that, mission will be on phase D for its spacecraft deployment and maneuvered constellation. After that, this mission will be having weekly science operations. For more information, please visit its official webpage. As I mentioned earlier, that our SunRISE GRL program is in the collaboration with Radio Jove. Radio Jove is NASA-funded citizen science project. Dr. Chuck Higgins is one of the lead member of this project, and he is going to give more information on this in the later slides.
Hello, my name is Dr. Chuck Higgins from Middle Tennessee State University, and I want to introduce you to the Radio Jove project. We are a NASA partner citizen science project. Below you see the names of many of my colleagues, and we are interested in doing radio astronomy to observe the Sun, Jupiter, and Earth-based radio missions. Our participants include radio enthusiasts, general public, high schools, and colleges and universities. As you see, our goals are to study the Sun and the planets using radio telescopes, but we also want to inspire you to become a citizen scientist. Learn science and the process of science to become more interested in science and particularly in radio astronomy. So we are here to help educate and provide a hands-on radio astronomy experience for you. You use your own radio telescope to observe solar system objects. And we have a community that allows you to participate, ask questions, and share your data easily. Below, you can actually see the hardware we use. The Radio Jove telescope uses simple wire dipole antennas and a commercial radio receiver. And with a Windows-based computer and software running, you can actually record solar bursts, Jupiter radio bursts, and other interesting radio emissions. You can see the cost is $220 for a kit, plus you would need a computer, and then additional cost for the antenna support structure. We have a website for all this information and an active email listserv. You can certainly contact me at this email address for questions. And on the right, you see a project, a citizen science project that we're currently working on to observe the solar eclipses in 2023 and 2024 over the Americas and you see a whole map of participants that will help us observe the sun so we can try to understand the radio propagation through the Earth's ionosphere. And lastly, I want to acknowledge our partners and our funding source. So you can be a radio astronomer. We are here to help. Please join us. Thank you very much.
Now let's move to the SunRISE Ground Radio Lab. The principal investigator of this project is Dr. Moshtaba Akhwan Tafti, who is a faculty at Department of Climate, Space Sciences and Engineering at University of Michigan. Our project aims to complement SunRISE space mission, engage public and educate next generation through the hands-on citizen science campaigns. SunRISE GRL engages citizen science using multi-frequency radio telescopes to observe radio emission from Sun along with the Milky Way galaxy, Jupiter and Earth ionosphere. To know more about our project, how to engage with us, how to participate in our project, and to know more about our team, please visit our website. Our team at the University of Michigan, Department of Climate, Space Sciences and Engineering will support the deployment of dual dipole antennas as well as training of the host high school staff and student teams. Our project is totally free of cost to our participants. Here, I'm pulling up a few of the major benefits to our high school students and the science community with this project. This project will inspire students to become a citizen scientist. It increases science literacy and understanding of the scientific processes. It will provide the hands-on experience in radio astronomy. It will also expand a network of radio telescopes for advanced projects. Our project enables access to online observatories and real data. It facilitates the exchange of data and ideas among participants. Our SunRISE GRL program is structured in the following steps. So in the very first step, upon the confirmation, high school staff will receive the antenna kits, which is expected to ship by this summer 2023. In second step, upon the successfully completing the training modules, a student will receive the certificate of participation in this project. The certificates are approved by University of Michigan, the Department of Climate Space Sciences and NASA's Jet Propulsion Laboratory. In step 3, the high school teams will host the antenna systems as well as collect data and upload it to our website. And step 4, upon the completing the training modules, the teams will have the opportunity to further participate in our science studies by radio science expert to identify events such as solar radio burst, auroral disruptions and Jovian emission. In last step or the fifth step, the team will have opportunity to participate in monthly webinars, question answer sessions with the SunRISE leadership team and other space science experts. Here I'm happy to share one of our best memory of SunRISE GRL journey. This picture is taken at the Department of Climate, Space Sciences and Engineering at University of Michigan with the Skyline High School students. This picture is on the day of successful test of our antenna installation session. That's all for this training module. For being updated, please follow us in our social media platforms. Thanks for your attention. I'll see you in the next module with more information.